All right, we are live. Thank you, everyone, for joining us today from the Althea and Dish communities, or those that are participating in the iFi or Infrastructure Finance Hackathon. We are here from members of the Dish team who are going to share with us some of their open source tooling, what that's all about, how to use it, how to get involved. If you have questions as you're going along, please feel free to pop those into the Twitter, Discord, YouTube or LinkedIn live chats. We'll try to keep an eye on all of that and get to either of those questions at the end, or we'll make them more conversational as we go along. Let's start out with a round of intros. I'll start with myself. I'm Deborah Sempier, co-founder of Althea and CEO of Hawk Networks, and we've built the underlying protocols and IP behind Althea, which is a machine-to-machine payment layer and dynamic kind of the telecom stack for building networks in places that it wasn't possible before. So joining me is my colleagues Justin Kilpatrick and Christian Borst. If y'all want to say hi as well, and then we'll turn it over to you from the Dish team.
Hey, I'm Justin, CTO and co-founder of Althea.
Hi, I'm Christian Borst. I am lead blockchain engineer for Althea.
And in case I'm finally coming through, I am David with the scientific staff at Dish.
Hey everyone, I'm Praveen Mada. I'm the staff AML engineer with Dish Wireless.
Amazing. Well, we are so excited to hear about the tooling. I think it's amazing to see Dish's leadership on open source and collaborative sorts of building and interoperability. I know I'm very excited to hear and see your presentation. If you want to go ahead and talk us through this, let's get started.
Yeah. So Dish, as everyone knows, we are building a 5G network, and because it's the first wireless network that's built to be a smart network, what we started with is the power of 5G network can only be open up once we start connecting and communicating with people as well as devices. From smart cities to smart networks to smart factories, the future will be built with microchips connected to wireless networks. Dish Wireless wants to be at the forefront of that. We are building the 5G infrastructure with that in mind so that we can unlock the full potential of the smart era. That's why our network is called the Smart Network, and we want to make the promise a reality. And coming to our vision is to change the way the world communicates, and our mission is to connect people and things. So, in the recent decades, there are wide range of technology advances that happened in areas around collecting the data, the analytics around that data, and machine learning, which is fueling the rise of smart era. Yet, the connectivity remains to be a critical barrier for realizing the full potential and unlocking the full potential of what's collectively called as Industry 4.0. Now, Dish has reimagined its network to be a connected platform so that we can unlock the full potential of Industry 4.0. You can also ask, how are we doing that? We have three important principles that we build our network around, which is open, secure, and flexible. So the idea is using these principles and re-envisioning how a 5G network to be built as a smart network. We want to unlock the digitalization potential that's sweeping the economy and also stimulate the future expansion in this era. And also in the next 5 years, the worldwide traffic of data will not be by humans. It will be the computerized devices without any human intervention that are talking to some kind of wireless infrastructure, wireless networks. So that's where we want to start with these three principles, where we want to open up our network, and also at the same time, we want to have a secure network where everyone can communicate through the network securely whether it's devices, whether it's people, whether it's enterprise customers. And also, we want to make the network flexible. What do we mean by flexible? When we start working with enterprise customers, there are different kind of problems they are trying to tackle. As the world grows and more IoT devices, more Industry 4.0 specific devices come live, their use cases are drastically different between different enterprise customers. So instead of building a one size fit all network, we want to build a network that could adapt, that would be flexible, that will be open for their enterprise customer needs. So we want to switch the control from the telco providers to the enterprise customers so they can come to us and say, this is a problem we are trying to solve, and we can build a network custom built and tailored for their use cases. So these are the guiding principles for building our network, and I'll be going deeper in each of them. So the first one is we're going to talk about open. When we say open, what do we mean by it? So previously, most of the telco networks that are live are vendor logged in most of the components. So we want to open that up and give bigger organizations as well as smaller organizations to be part of our smarter network ecosystem where we have open RAN and open APIs. What do we mean by open APIs? Is opening up all the data that our network is generating so that we can provide visibility for enterprise customers to better understand their processes and to optimize the process so that they can get unlock the full potential of a 5G network. And we also want to have open partnerships with developers, with enterprise customers, with startups. So we want to build an ecosystem where everyone can openly collaborate and try to fuel the innovation through network. And just to go deeper onto that, for us, open is not just a buzzword, it's a mindset. That's where we started with our team, where most of the work we do which is open source. And we want that to dictate and inform every aspect of our business going forward as well. So the first step we started with was building an SDK, because 1 year ago when I started with Dish Wireless, we were building the network as well as we are trying to understand the data that is generated by the network. So if we can build tools that could help developers who will be onboarded onto the ecosystem faster and efficiently, they can start looking at the data on day one. That's way more valuable for the developer as well as for the Dish ecosystem we are building. So we started with a toolbox, which is, as of now, our team is building tools across like ML focused data products. But we also want to invite developers onto our developer community to be part of the ecosystem, and let's together innovate on the ideas. And then we need to also figure out how to monetize the network as well. That's where we want to bring in open source developers to start looking at the data the network is generating, start understanding the 5G network, how Dish build it, and let's work together to monetize the network. So the second tool we built is the distributed ML framework. The idea behind that is, as we are working with multiple partners across different components of the network, from UE to RAN to the core, which is distributed across multiple data centers on AWS, we also have the data that's been distributed across multiple AWS. As of now, we are running on AWS because we have like enterprise customers who are generating data, who are holding data in S3 buckets separately. So we want to figure out how to bridge a connected future through collaboration. And that's how we came up with this ML framework, where wherever the data sits, we want to leave the ownership of the data with the enterprise customers or the partners who are generating the data, whereas our team would be only accessing the data to better understand it and also to build better systems. So if you look at the architecture diagram, the far left has like S3 buckets. Those S3 buckets could be geographically distributed across multiple data centers, multiple AWS accounts. And the S3 bucket, which is at the bottom, is the S3 bucket that our team uses, which holds the model parameters, also the feature engineering data, the model code, and everything. So what we are trying to do is we are trying to build a framework that could work on any cloud, any compute, and there is a decouple between the compute you use and the code you have to run. So if you look at the next box, which is data preprocessing and preparation, we use Spark for reading data and also with Python, but our compute could be SageMaker, could be EC2, could be EMR cluster, could be EMR serverless. So our code sits in GitHub, which is DishDev XSDK and EKSML pipeline. Those are open source repos if anyone is interested in looking at those. Those are available on our DevX community. And the next step is the model training, where we have most of our code written in Python, but we can also write it in whichever the programming language the developer is looking for. We already have connectors to the data. The data would be available to the developers on day one once they get onboarded. And as of now, we are using SageMaker Studio and EC2s to run our training. And then we deploy our model on EKS clusters because this is more focused around like the core of the 5G network. As of now, we are running all our network functions, which are part of the core on EKS clusters. So you could run on Kubernetes, or you could just deploy it on Lambdas, SageMaker outputs. So whichever we want to provide the flexibility to the developers, where we don't want to confine the developers to use a specific set of tools. We want to open up the toolbox and add more tools to it so that every developer can have the freedom to build and implement their idea however they want it. So that was the idea behind this tool. And next part is talking about secure. At Dish, we have a slightly different approach to secure because we are building our network as a transparent ecosystem, which means that as we are exposing all the data, we are not just building a network, but we are also providing an observability tool for our enterprise customers and our retail customers. So how we do that? Because the telco is a really enormous, complicated tool that's running on our cloud. So the data is also complicated. We figured out a way to properly structure the data using transparent data mesh architecture. Now, it's humanly not possible to look at all the data points that are generated on the network. So we want to outsource the observability to AI or ML models. So for that, we built an open source autoencoder as an observability tool that sits on as a layer on top of the network that looks at the core data that's getting generated. It looks at the compute information. As of now, it's on EKS clusters. It looks at the metrics information. And also in the future, we'll be looking at all the logs that are generated by our network functions that are part of the core. And we want to expose that. And then we run it through our autoencoder. And that's how we want to provide observability through our network to make it secure and give the tools to the enterprise customers who are using the network because they know their use case way better than a telco provider would. So we are building tools to hand it over to enterprise customers to take full control of the network and also to unlock the full potential of the network. The next one is flexibility. As I just mentioned, that our network is built on AWS, which is distributed across data centers in whole of US. We think of our network as a hyperscaler because we have like LDCs, PEDCs, BEDCs, RDCs, and NDCs that are distributed across whole of US. And we just finished our 75% for the FCC deadline a few months ago. So that's why we envision our network also as a hyperscaler. We are not only just providing connectivity, we can also provide compute for the enterprise customers who wants to run their applications closer to the devices where the data is getting generated. We can help them and build a better hyperscaler fit for their use cases. If they want to run a live inference tool, we can come up with a solution to run their applications at the edge, and then we can move the data up to NDCs for them to run their training, the simulation tools, and all of that. So that's the idea behind a network being flexible. So how we are going to build a flexible network that's specific to the customer's use case. So our team came up with a concept called reward engineering for self-perfecting open networks, which is having an RL agent running as part of the network. As of now, we only have one RL agent, but in the future, there will be multiple RL agents running at different data centers and as part of different network functions, which are monitoring and taking actions based on the data the agent is looking at. And the main two components of that infrastructure is FONPR and NAPP. I'll be focusing on NAPP, and David Cherney will be talking more about FONPR. What do we mean by NAPP? NAPP is network as a NAPP. Instead of running the whole core on a distributed environment of data centers, what if we can run the whole core in a single EKS cluster? So how we did that is, instead of running our macro core, which is part of our 5G network, we went to the open source community and looked at multiple open source cores that are available. And we picked Open5GS because it's one of the active community. There are a lot of documentation available for them, and there are also like really good support available for Open5GS. So that's why we went with Open5GS as our core, and then we used UV RAN Sim for our UV and RAN simulation, and all of this setup is run on Kubernetes. So why we did that is to build a truly elastic and scalable application on Kubernetes. We do not look at our core as a telco. We want to have like a software. We want to treat it as a software. That's why we built a standalone 5G core, and we consider our network functions which are part of the core as applications. And we want to figure out if we can scale the core based on the use cases the customers present to us. So this Open5GS plus UV running on Kubernetes is our NAPP, but we also need observability and the management tool to run the whole core. So we build an open source monitoring and management stack for our core, that's NAPP. So we used Grafana, we used Clonebit and Prometheus for our monitoring, then we used Flux for our management tool. So combining our monitoring and management with our Open5GS and UV RAN Sim, we run our EKS or NAPP on the EKS cluster, so that we split an EKS cluster into two different namespaces. One is for the observability and other is for the open verso, which is the Open5GS stack plus UV RAN Sim. And then we start collecting the data. We dump that data into an S3 bucket. Then our data science team comes in and start looking at the data, make sense of the data, and then figure out which RL agent need to be deployed to build a flexible network. So next, Diva will take over how we build FONPR.
Thanks, Praveen. FONPR is our product, our first open network pattern reactor. The idea that I have is that we have maybe taken a blindfold off of this network and allowed it to look in the mirror and allowed it to be given with an idea of what perfect is. That's where the idea of reward engineering comes in. What ideas about perfection is this network going to have? And how is it going to change itself in order to head in the direction of that human-defined notion of perfection. Next slide. There's a lot of different facets to being perfect, right? There's a lot of different aspects of the network that we could try to polish and make smooth and beautiful and shiny. And we're just going to share with you one that we have tackled, but we want to put the idea out there that there's a lot of possible applications of using 5G connectivity and cloud computing and 5G core. And we are eager to interact with people who have asks of our network, that have ideas about how they can use 5G connectivity and want a community to help develop those ideas. So if your facet of interest is not mine, though not the one I present here, let's talk. Next slide, please. So which facet did we decide to attack first in telling this network how to move closer to perfection? We thought about the structure of a 5G core. There's this concept of the control plane and user plane being separated. The user plane has just one function, the user plane function, UPF, whereas the control plane has a bunch of functions. And next slide. We thought, let's just pay attention to the user plane. Okay, so we have a UPF from Open5GS. We have a simulation of base stations and user equipment from UE RANSIM, and we have it access the internet and generate a bunch of data flow across the user plane. How do we make this more perfect is our question. Next slide. We have the idea of scaling. Go ahead and toggle through these slides, Praveen. As you get more traffic, you'd like to fire up more resources to handle that traffic. And if you have less traffic, you'd like to be able to scale down resources. You see, the more resources that you have fired up, the more you are paying per hour. And you'd like to have something like the minimum amount of resources deployed that is necessary to be able to handle the traffic with the desired quality of service. Next slide. So we decided to tackle the problem of dynamically scaling the user plane, to have this network look at itself in the mirror and say, am I perfect when it comes to dynamically scaling the user plane resources? Or should I look in availability zone 1 in a node group of small nodes, and should I create a new node, a new virtual computer, something like that, that allows me to handle additional user plane traffic, because I've recently started handling more data flow. And so we set up this system with the capacity to add or remove resources from small node groups, that is, groups of nodes that are small, each individual node is small, or large node groups, that is, each node individually is a large node, in multiple availability zones. And we had this network observe itself and see if it is as close to perfection as it can be. Next slide. The thing that we told the network is the direction of perfection in which it should head is a pretty simple idea. It's just the idea of optimizing profit in the form of revenue minus cost. The revenue comes from serving user plane traffic. You could think of this as charging for a megabyte of data that passes through the user plane at a certain rate. Okay, so the more data that successfully passes through the user plane, the more revenue. And if there are not enough user plane resources, if there are not enough nodes to support the traffic that the system is trying to push across, well, then that's a lost revenue. Okay, so the system with this desired function to optimize is going to try to serve all of the traffic that comes at it by firing up enough user plane resources. On the other side, in red, there's the cost. The cost to us, the cost to Dish, is having a node alive. Right? The longer that we have a node fired up, the more we have to pay. And so we would like to get rid of those nodes whenever possible and have the minimum number of nodes needed to serve the traffic. Next slide. One really cool thing about this technique called reinforcement learning is that it is equipped with something that us humans are naturally equipped with. If somebody were to offer you $50 today, or alternatively, $50 later, say next week, you would certainly choose $50 today. We all would, because we have an intuitive notion of future discounting. The future is uncertain. So the promise of $50 in the future is worth less to us than the guarantee of $50 today. Next slide. Reinforcement learning takes this into account. It not only takes the past trends and guesses what the future will be, $50 now, $39 next time step, $84 next time step, but it also applies discounting to the future, because the amount of traffic that is going to be coming across the user plane that can be forecasted, but that forecasting is going to be less and less accurate farther out into the future. So that anticipated reward out there in the future should be discounted, and farther out in the future should be more heavily discounted. So the reinforcement learning mechanism that we built in to FONPR makes decisions with long-term future discounting in mind. And that's a beautiful system. Next slide. So again, that was one facet of perfection, right? Perfectly scaling up resources to handle user plane traffic. One could also do this for control plane traffic or any number of other aspects of the network. And the idea is that we built an open source repository that developers can access and start developing a reward function that leads a network towards the developer's notion of perfection, to make another facet of the network shiny and perfect. Next slide. So, our first open network pattern reactor, FONPR. It takes the blindfold off of the network and allows it to look in the mirror and see itself, and to take action to change the network in response to some reward engineering done by a human to get closer to perfection. Next slide. So, Dish has reimagined networks as open, secure, and flexible. And my part of the presentation, presenting the first open network pattern reactor product. That's all about flexibility, right? The idea is to allow developers to come in and use that flexible reinforcement learning tool to enable the network to move closer to any notion of perfection that the developer comes up with.
Awesome.
Next slide. And to know more, we have all of our code up, open source at GitHub. We have some articles on Medium there on the right about the work that we've been doing. And to look at Dish's websites per se, right there in the middle. And thanks for the time, Deborah.
Yeah, thank you, David and Praveen. Really exciting stuff. I think there's been some really exciting both conceptual things and some tech here that's very cutting edge and exciting. I'm going to have Justin talk a little bit now about how, if you're a hackathon developer, if you're thinking about building Althea, maybe you're building an Open 5GS, the Althea the LTE is based on Open 5GS2. Maybe you're thinking about interoperability. Justin, tell us how do we merge what we've learned here in the first part of the presentation, with maybe some ideas that are in the back of developers' minds right now.
Yeah, so I'm going to start with just some sort of scene setting, and that is that right now, for the first time ever, it is essentially possible for anybody to start and run a small LTE network. And this brings the enormous amount of connectivity capability into the hands of smaller operators, smaller networks, or even just the general public. And what we are talking about here is that is part of a larger transition in the telecom industry. And that is that we are moving from $1 million hardware boxes that are the core to an LTE network to open source software. And this open source publicly available software is easier to tinker with, easier to iterate on, which is why Dish is using it to try and optimize their operations, to try and reduce costs. It gives them that visibility and that ability to reach into the internals of the system and optimize it for their very specific needs, rather than buying an appliance, a very expensive appliance from a company like Ericsson. So this is the same thing that happened to networking in general, 5 or 10 years ago, depending on who you ask, where it was transitioned from hardware networking to software-defined networking. And now we're seeing software-defined LTE, software-defined telecom. And this is where we get into what's really excited for hackathon members to work with and sort of hack on, and that is that so Hawk Network sell a kit for a private LTE network, including a router that runs Open 5GS, that runs the Open 5GS user plane, and you can experiment with your own LTE core. How to optimize it, how to use it, and more importantly, going into the future, this interoperability and cooperation between different telecom companies. Previously, different telecom organizations that previously kept everything secret, behind closed doors, extremely expensive, impossible for an individual to set up. Whereas now we are looking at private LTE networks powered by Althea that anybody can use and anybody can join and start roaming between a Dish operated core or an Althea operated core, or any user operating an Althea powered KLT core. And this cooperation is going to do the same thing it did with software-defined networking, which is that software-defined networking was so much more flexible and so much more efficient than the old monolithic cores, that it really completely took over the market. Nobody is using giant $1 million routers anymore, except outside of very specific applications. And even those, they're eyeing them, side-eyed, like, can we replace that yet? We want to get to it. And that's what we are on the cusp of with LTE. And this fundamentally changes the way data is bought and sold, and is part of why Althea and Althea L1 exists, to make it easier for people to buy and sell data and to turn data into a commodity rather than a lock-in based network. And this is how we sort of break out of nationwide networks being the only way to buy and sell data, and move towards a data economy that is practical for 5G. Because the whole issue with the 5G architecture and the machine-to-machine networking problem is that if we assume there's going to be this much data and we need to use higher frequency radios with shorter range, no one company can set up that many towers. The old model of a giant tower network owned by a single company starts to break, because when you need a tower in every block, you have to share them somehow. You can't have 6 different companies building 6 towers, 1 per block. The end result would just be complete chaos. And that's where you need open networks, open cooperation, and open source software, making it possible to really deliver this 5G and IoT vision and deliver high throughput data everywhere. So yeah, let's see. I think that's enough for like trying to connect all of this together, and how Dish and Dish and Althea are both working on Open 5GS as the future of an open LTE core, and how it's possible for normal people to use these, to now use LTE products and to actually build something with them. So in our Discord, I'm dropping a link to our KLTE starter kit. But if you just want to play around with some software, there is plenty that you can do right now without any hardware. So if you grab the firmware we have here, you can spin that up in a VM and it'll run Open5GS for you and give you an opportunity to experiment. We also have our Open5GS fork here. So this is Althea's KLTE Open5GS code. And then I'm putting this all in Discord, by the way, since YouTube is a little anti-link. But then let me go ahead and find Dish, because Dish's Open5GS is also available. And the really cool thing is that we are getting to share improvements, share code changes, and work together on the future of 5G and LTE while also working together with everybody else who is sort of congregating around Open5GS as this future of software-defined LTE and software-defined, this sort of next generation of software-defined networks. Okay, I think that's enough for an intro, and now we can get to questions.
Yeah, I was actually really appreciate kind of that perspective on interoperability. I keep hearing this open network, open source, all the kind of themes from both teams. Love to kind of kick it back to Dish here. Praveen, David, do you want to share some thoughts on open networking? What is that interoperability piece is? How can builders plug in to kind of both stacks at the same time, really using that dynamic and that the advantages of being dynamic and agile and smart, especially I heard from Dish in the beginning, right? How do we build the smart networks? How does Dish and Althea teams kind of work together? Love to hear your thoughts and comments. Praveen, David.
Look, if you want to be smart, listen to a lot of people. There are a lot of people that can come up with ideas different than the ideas that I can come up with, right? So if you want to be smart, the opposite of a good strategy is to take all of your software and lock it up so nobody can see it, to take all your code and hide it, to take all your data and hide it away, right? You want to be smart, don't rely on your brain alone. Open up your data, open up your code, and invite people in, and get as many ideas as you can, and work on lots of different things, listen to lots of voices. And that's what we're trying to do here. As Dish moves from building out a 5G network that covers 70% of the US population, that's primarily designed to handle cell phone traffic. We are moving into a period where we are trying to listen to as many people as possible, no matter what company they're from, big or small, working on their own. I often joke that we want to build things that enables Tesla to do self-driving cars on public roads, and we also want to enable Greg to make his 5G cat tracker. All of it is important because there will be important ideas coming from all of those different places. So we eagerly invite in the developer community by sharing as much as we can.
Yeah, I appreciate that perspective. I think we share that open source is really the key to innovation and growth, and it's good business, right? Oftentimes people think, hey, how are you going to make money if it's not closed source? But I think that you really hit the nail on the head, right? It's really that creativity, that innovation, and the internet's a series of tubes, So to this point earlier, you don't really get very far without interoperability and that openness and that innovation and creativity. And for me, it's been such a privilege over the last, as Justin kind of said, 10 years to really see the industry evolving and changing as those demand sources, whether that's Greg's tractor or Tesla or IoT, but machines are really becoming a lot more smart. And so having a network that is adaptable to that is so important. And I think what's so exciting right now is we're really inviting in new builders that can take advantage of these tools, whether that's on the Althea side or the Dish side or together, and really build something that brings value to them, brings value to the ecosystem, and they can do it in a pretty lightweight way. And these tools are pretty smart themselves. So that's what's so exciting to me. And if you haven't yet, the QR codes are still up on the screen. Please feel free to link those. We'll try to make those available, of course, after the call as well. Christian, I don't know, you've been pretty quiet here. We haven't had you talk yet, but you're an Althea lead blockchain developer. I'm wondering what's kind of tickling your brain as you're listening to this, if there's ways that you're thinking about how the blockchain components are coming into this.
I think especially when it comes to the upcoming liquid infrastructure features, I think this is going to be really interesting to see how we can tie all these things into making devices and products that themselves can be commoditized on this, data as a commodity network. I think it's going to be really interesting to see what the future looks like, because it really opens things up to make just more people able to participate at the infrastructure and at the user level than ever before, in a much more freeing way.
Do you want to tell us what liquid infrastructure is for the folks in the audience that may not know? How do we liquefy telecom assets?
So liquid infrastructure is, to my knowledge, one of the only useful implementations of an NFT. So basically, we are tokenizing a piece of infrastructure that operates on a network like an Althea network. Basically, anything where a device makes routine transactions in tiny little increments, like microtransactions, to pay for the use of bandwidth, to receive money for serving bandwidth, or it's not just related to data. It can be, you could commoditize like an electrical grid device this way, just so long as you have that microtransaction layer, and convert that from a device that has its secret keys stored on the device and needs to be managed manually by the device owner. You can tokenize it and give the control to anybody who owns the NFT underlying the implementation. So that NFT is the critical part, and you can trade that around just like you would if you were buying and selling artwork. But instead of it being a piece of art, it's something that generates revenue for you automatically, passively, and is a critical piece of any sort of network that has microtransaction payments. So it's going to be really exciting to see how people can set up devices, and it's going to be easier to control them, easier to collect profits from them, and much easier to kind of build infrastructure and then sell that to anybody who wants to manage it, rather than needing to do the building and the management all as one organization. So very exciting stuff.
Yeah, and I just wanted to take a moment to connect this to sort of the 5G, the 5G narrative. So right now, what we have what we have deployed, and by we, I mean like what currently exists and what you're using and what you call 5G when you see it on your phone, is the 5G network protocol on running on the old frequencies. So it's the same frequencies as before, roughly the same data throughput, but a lot more programmable. But 5G was really designed to shine in a high throughput IoT environment where you have really high frequency towers with enormous data throughput that would allow cars, IoT devices to really access the internet with no connectivity limitations. But to do that, you need towers that are everywhere. The range of these higher frequencies is measured in, feet instead of miles. So the issue with building a network that with building a 5G high frequency network is that you need open RAN, open radio access network. You need some sort of cooperation between providers to make it practical to run these high frequency towers, to build enough of them and operate enough of them that an IoT device or a smart car can have that gigabit access to the internet just driving down one street, because you'll need to hit 4 or 5 towers along the way. So that is where Althea sort of connects liquid infrastructure to this concept. We are looking at the future of telecom and seeing that it's more open, more cooperative, and more importantly, it involves a lot more people doing stuff. So how do they all pay each other? How do they all? How do you deal with the financial aspect of this enormous cooperation burden? And that is where Althea and Althea L1 comes in and says, okay, what if we made it really easy for payment cooperation between these open networks? And we made that automatic, commoditizing bandwidth. And this is where this is the connecting point between all of this open 5GS, open RAN revolution, and Althea and Althea's billing system, is that you kind of need some sort of open billing system to go with your open RAN, or why would anybody build these towers? So this is where it all comes together. And I hope that I'm presenting this well to a more general audience, because I know we have a lot of telecom people around that are seeing how this all comes together. But it's always really exciting to explain it to people who might not be paying all that much attention to exactly how 5G networks are built.
Yeah, and I'm really glad you brought up Open RAN. ORAN has really shown a lot of leadership in that respect too. Really want to applaud their efforts on that. And I'm glad you kind of tied those two in together too, because I was thinking, David, as you were presenting this idea of sort of dynamic resource allocation, combine that with Althea's payment layer. Maybe when bandwidth is more expensive, it's more expensive to the user, or you have like somewhat of a bandwidth marketplace. I'm curious if that's kind of what you're thinking as well, is when you have that kind of payment layer that Althea has, the machine-to-machine programmable transactions, how does that fit in with your smart tooling? Oh, you're muted.
I'll start by saying it's absolutely true. Dish cannot build all of the infrastructure that is required for the anticipated future of 5G. We need lots of help, and it's not a matter of competition. It's not a matter of there being a pie of a certain size and us getting a big slice. There's enough for everybody, and the more people that participate, the better. And for the pricing, yes. So we would love to see some developers come in with ideas about how to use the UPF, the user plane function, and traffic that goes through it, and usage reports from it, interact with non-fungible tokens, keeping track of who's providing the connectivity, and doing a dynamic charging based on all of that. So bringing in a charging function into the Open 5GS stack would be very valuable, and I'm sure would stimulate a lot of discussion in the community about ways to proceed.
Yeah, very exciting. Any other ideas that you're thinking about? Hey, this is what we would love developers to build, or this is like a need in the industry. Where are your kind of thoughts around on that? What you'd like to see happen? David, can you share some thoughts on? Do you have some ideas around what you'd love to see the developers build?
So what I'll say is that my feeling is the smaller, the better.
Oh, okay.
So often when I am reading academic articles, the focus is on smart cities or energy infrastructure and these very, very big companies. And I don't find that nearly as interesting as small ideas I want to, like you said, it is now an age where a person can sit down and fire up an LTE core on their laptop, right? And I am excited to see where that goes. And I'm excited to see the kind of creativity that the community has. And I think a lot of ideas that will eventually enable the big things are going to come out of those small projects.
Yeah, I love that idea you're talking about. Hey, Greg, on his tractor there, what does he need? Maybe he needs some sensor management. Maybe so he pulls out his laptop, and there's just innovation that comes from that need, a DIY culture, just sort of solving your own problems. And I'm really so excited to see that this has been, not only welcoming of new developers, but creating these tooling, right? So this sort of portable tool stack that you basically need to fix the tractor from a smart perspective. And then you bring out your little, toolbox of, these different sort of modular kind of smart tooling. And it's really so exciting to see. I think we're kind of coming close to the hour here, and I appreciate everyone sort of sticking around for a fairly meaty discussion. Praveen, thank you so much for really presenting how all the tools fit together. There's a lot of depth there. I'm going to sort of turn that over to you to closing thoughts, and we'll kind of close up the last part of the hour here. But anyone could please feel free to find us in Discord. I believe parts of the Dish team are also in Discord as well. If you're hacking, if you have questions on how to use tools, there's the Althea Discord has an iFi Hackathon room. Please feel free to join us there at myself or Justin or Christian, and we'll make sure you get in touch with the right folks and look forward to building together. And Praveen and David, if you want to give us some closing thoughts, we'll close it all out. Thanks so much.
Yeah, I just want to start by saying thank you, Deborah and Justin and Althea team for giving us the opportunity to share our work. And all the tools we build are open source. Any developer who wants to look at it, those are available on GitHub. And we are also looking for developers to be part of our developer community to start bringing more collaboration into telco, as well as solving innovative problems like we are trying to do. I think if anyone is interested, do reach out to us through the Discord, or we'll be sharing a Slack channel later with Deborah. If you can just plug that in as well in the later part of the hackathon, that would be really great. So I think that would be a really good way to reach out to me, David, or any of our team members. And if you have any more questions on the tools, we are happy to answer that as well. And thank you, guys.
Cool. Yeah. Thanks, everybody. And, so I really appreciate y'all coming here and, Dish coming here and presenting this. And I'm really excited for a future of cooperation in open telecom. And yeah, as for what I'm excited to see people build, there's a lot of cool possibilities here, including IoT sensors. I've always loved IoT sensors. And, if I had the time, I would be building like 6 of them. So, but yeah, so anything like that, I'll find really cool.
Well, thanks again, everybody. Thanks for joining us and taking time out of your day. Dish team, super excited to work together with you kind of going forward. And thanks again for all of your work. Very inspiring. Thanks.
Thanks, Deborah. Thanks, Althea.
Thanks, everyone.